Alright, I'm back on the boat and have done a little preliminary troubleshooting after Joy has worked on it. What I can tell you is that it is not pumping fuel. I've gone through, checked the prime. I've actually bypassed, and you can kind of see I have a little fuel line with some fuel in it right there, and it's just not moving fuel. We have cleaned the internal filter. There was nothing in there. I've changed out the solenoid that controls the fuel shutoff, but that's only to the nozzle. We're just not moving fuel down through the pump and out the return line. I've actually created a little vacuum on the return line, which is down here. That did not make any difference. And we have changed out the main fuel filter. I have pulled the fuel up through that hose. Right now it's disconnected down here, because I don't know if you can see back there, but there is another temporary fuel line full of diesel going up to that one, and that has not moved during any of the cycle starts. So we're going to go ahead and get this completely uninstalled. We're going to tear it down again, probably for the 4th or 5th time, and look for any kind of blockages. Look at the fuel pump and figure out if this is repairable. Getting parts for this is getting really difficult. This is an old original hydronic 30, and it's just they're special order in many cases. The hydronic 230 shares many of the same components and part numbers, so the question is whether we're going to get this working, or we're going to replace this entire unit and keep a lot of the spare parts, because like I said, again, they're interchangeable between the two units. But it worked great for about a year, and then it one day just wouldn't ignite. We hadn't changed anything. It had been running on and off, and just stopped. So went through everything, checked for spark, we have spark. We're just not getting fuel flow because we don't have anything in the return. And when I opened everything up the first time, there was no fuel in the return line. On an initial disassembly, I didn't get much. So let's get this apart. Alright, I'll try to stand a little bit out of the way, but no promises here. So the first thing is to get the cover off. We're just going to keep that little fuel line up there for a minute because it does have a little fuel in it. Now, we don't have a lot of room, unfortunately. Let's see if that gives us a little more light. And you don't want to drop the washers. Don't ask us how we've done that before, because it falls down, tumbles between a bunch of little hoses and stuff, and then somehow it always ends up in the bilge. And now the easy part, it slides down and goes down deep. Alright, so that's the cover. This is your CO2 adjustments. I have some previous marks when I've actually set the proper levels. Alright, we're not going to need that for a while. Unfortunately, we cannot unscrew our fan. It is corroded there. And we tried to use the screwdriver to hold the motor shaft. The little slot where the screwdriver is, it broke off the slot pieces. We tried clamping on it with a pair of vice grips, and it was still so frozen it wouldn't come loose. What I'm going to do here is, before I get anything more loosened, get in here and get these connections undone. You got to get your fingers in there and kind of work them back and forth. Pull this grommet out. And those are the sensors for water temperature. Okay. Now, let's see if I can get you up here, guys. I'm going to take out the whole wiring harness. So we have two master connectors here. There's one. And for whatever reason, they're super hard. They were all tucked up in the nice wire chase, so we get those out of our way. And I'll show you guys later, but if you get to the point where you get a lockout because too many starts, rather than getting here, you can actually come back in here, and I'll show a diagram at some point. And all you have to do, in our case, is we short the red and the yellow with the red stripe. Turn it on, put a little jumper. In my case, it's just a little paper clip. Hold it for at least 3 seconds, 4 seconds. Remove the jumper. Power it off from the master power switch. Turn it back on, and that will reset it and give you another 10 cycle starts. All right, next part. Get our little retaining rings here. And these are big nuts with a washer, just like that. This is the tricky one because the exhaust is right in the way. So the secret here is not to drop the washer. And the exhaust lagging is right there. Okay. So once we get it off, we'll go ahead and remove the fuel. I'm gonna try not to make a big mess with my temporary hose. So one of the things is I went ahead, checked the actually I had a spare nozzle, put a spare nozzle on it, and I changed the electrode probes. This was really melted kind of bad. It was just a big mess. So we went ahead, and when I popped it apart last time, it just broke in half. Alright, so let's see here. You know what, I think we'll just leave that hose there for a moment. That's the return supply. Just slightly wet, that's something new. But it still didn't suck the fuel. I'm going to leave this little temporary line on here. We're going to move it over to the workbench, and I'll grab the camera and be right back. Alright, so back over here in the utility room, move the pump over here. It's going to get a little hard to film, don't have much room, but let's take a look at what parts we do have. What I want to show you down over here, this was our spark generator, melted really bad. So it's still working, but the electrode probes don't lock in real tight. Because we weren't getting fuel, I went ahead and I actually put a new solenoid unit on, 24 volt. This is the old one, works fine, so that wasn't the problem. When I removed it, put the probes, you can just see it just broke in half. Probably would still kind of work if you wanted to glue it, but we have a new one, so we put the new one on. All right, so what we're going to do is get this part of the assembly off, and we're going to see if we can get, just as we dig deeper into the fuel pump, and just see if we can get any fuel flowing. All right, let's start getting this a little bit apart. So first thing is we're going to try to work out this electro probe, and this new one fits really tight. Don't want to break it, so I'm just going to gently twist it up and out. There we go. Need to get the nozzle off. Not sure if I brought the right wrench in or not. Nope. Alright. We'll just cheat and use a little adjustable wrench just to hold that. There's the fuel nozzle. You want to never touch the strainer part. Pull this little retaining clip out, it just slides off. There's the flame shield. We're going to go ahead and take off this is a little power source generator for the electrodes. And we're going to spin around and we'll take off the solenoid. So let's get some of these wires disconnected. Maybe. Don't want to break them, but they are really tough. Don't really want to use pliers yet. See if I can just get under the little tab. There's no locking tab on them, they just push in. See if I can kind of gently grab it. Well, not having any luck there. Let's go ahead and get our little solenoid out of the way. Now one thing is there's a recess in this nut. The nut only goes on one way. So thread's there and it mates over a smooth part of the threaded shaft. Well, we can just pull this out. We'll get it unplugged in a second. And we'll leave it in here. There's a square mounting part and a Belleville spring washer there. That's not going to interfere with this at the moment, so we'll just leave it like that. Set that over there. All right. And let's go ahead and take off the coil for the electrodes. Just 2 little screws. There's a little washer. Nothing there. Yeah, they're just slide in friction fit. They fit tight. And this should be for the little preheat module. All right. So this is the fuel pump module and the preheat. And it's 2.5 millimeter. Get them all loose first. Yeah, I wasn't paying attention and there we go. Well, our little tube full of fuel is now dumped on the floor. Had maybe 2 tablespoons of fuel in there. So now it's going to smell like diesel. Alright, where are we? Let's get the last screw. Set our temporary hose there. And these 4 screws are all the same size, and they're silver in this on this build. Now I'm going to guess at this point, since there's no parts diagram for anything underneath this, that they consider this not to be serviceable. Okay. And there's only one orientation here, because there's a little O-ring that goes up through there, and that is where the shut-off valve, if that's open, it's going to let fuel up here, go through this little hole, and come down inside here ready for the nozzle. And there's an O-ring sealing that. I'll just set that over here to the side. Let me give you a little better picture. So under there is going to be the gear-driven fuel pump. Now at this point, we should be able to do a little experiment and see if we can get air to flow through here. So we're just going to actually go grab our vacuum pump. We'll swap out hoses. Alright, that'll be good enough. Alright, so just for fun, we're going to take it on the, pull a little vacuum on the outside. And it is dropping, so we are pulling some stuff through. But I think it should be, yeah, it's holding now. Now it's holding pressure. So, why aren't we flowing? On the input side right here, there's a banjo bolt. I've had that off. Once upon a time there was a filter system in there. You can't even buy the filter anymore for this model. So now it's just, there's a metal screen, but we just replaced the main fuel filter going in, so not overly worried about that. Let's go ahead and pull this banjo bolt off this one, and it is pointing downward. Oh, I need a little hammer. Just give it a little blow. And one little copper crush washer. Yeah, there's nothing blocking this one at all. See all the way through it. So don't know what to tell you about that. But borrow your flashlight. Yep, as long as we're looking for clogs, let's open it all the way up. Yeah, I'm not really sure what the purpose of these are. It's like a little needle seat, but there's no needle or anything in it. There's a hole, it's just brass. Doesn't appear to be anything in there. Let's see if anything falls out. Nope, nothing that I see at the moment. Now, I assume this is some type of bleeder valve, but what it does or how it works, it's plumbed into this, I don't know. And that's not a, well, that looks like it's a bleeder valve. It is not. That is a button head screw with a tightening nut on it. And I cannot find this on any of the drawings I have, so I don't know if this was factory. Somebody took out a bleed screw and replaced it with a bolt and a nut. I'm not sure. And I assume that was a yeah, I don't know. That's actually, it looks like there's a solid piece in there. All right, we may take that out in a little while to take a look at it. So let's take, for the fun of it, let's take our vacuum, pull a little on the input side. It bleeds down pretty quick, but so what I'm doing, if I block the output, that holds suction. Well, let's open up the fuel pump and look at it. See if we can find any reason why this isn't working. I did read something in some brief little blog that it's based on some kind of clutch. Alright, there's 2 black screws and 2 silver screws. The black screws line up with the output. The silver screws and the plate line up with the fuel input. Now we'll start a new little organization pile. We're going to pull out the silvers. Again, the silvers line up with the input in case I forget and have to go back and look at the video. I know my hands are in the way. So the black screws are longer. I'm just going to put a little mark just a little index mark here and here so we know which way the plate came out. Grab a little pick. Alright. So it's just a plate. Little gear driven fuel pump. Let me bring you guys around. See if I can zoom in. So it's a little gear driven plate. I don't know if there's a diaphragm or something in there or what. I don't see how we're going to get fuel. I know they talk about having a little negative pressure, and I wonder when the fan is blowing if that's creating a little negative pressure, but I don't understand what they're saying in the manual. That's what it comes down to. They have no way to measure fuel flow volume or anything of that nature. And they say that right in the manual. They have tests for everything else, so let's keep digging in and see what's happening. So let's just, now that that's open, let's put a little vacuum on it, which is what we expect. All right, so let's see if we can gently get, there we go. Alright, so there's our plate, one gear. Set that face up. It's coming out of here slowly. Alright, we'll take out the other little secondary gear. It's not on a shaft, it's free floating. It's not on a driven shaft, I should say. Okay. Now there is, on this shaft, there's a little tiny ball bearing. And that, I don't know if you guys can even see, super small. And that driven gear, or the gear that rides on this shaft, is captured with that little ball. Now what I don't know is, I think the shaft is supposed to move in and out. It has to spin in here, because if you spin the fan blade, that's what spins this shaft. Alright, we're going to be real careful not to drop and lose the ball right now. And take a bigger look. Give you a picture here. And I think the green is just a spacer material. I can't tell. It doesn't appear to be a gasket. And it's not horribly dirty in there. So we'll put a little vacuum here. See if we can figure out which hole is providing stuff. It should just be that hole right there. Nope. So, don't seem to have any flow problems there. So this is where the operation gets confusing. I'm going to see if I can take this little ball out without losing it. Tell you what, let's try it with a little magnet. Whoa. And if you guys want to see, there's that tip of that little ball. Alright, we're just going to keep that on the end of the magnet. And this little shaft just rides in here, but it goes up and down. And then it goes, there's a little flat on the shaft, it drops down into here. So it engages there. So whenever that is, when the fan is spinning, so I'm spinning it manually, it's spinning. Alright, I'll take off our little solenoid spot. It should be riding right there. Pull it out real gently. The thing I find odd, if I grab our driven gear, or the shaft gear, and there's that little, I don't even know if you can be able to see it here. There's a little round cutout. But if the shaft is pushed all the way down, the gear is not engaged. Which is really strange, because I would have thought they would have driven it. I mean, it's almost like it's almost like when this is spinning, if the shaft is supposed to move up, the ball then grabs, slides into the gear and engages the gear. But that doesn't really make any sense. Why wouldn't you keep it a direct connection all the time? And what actually is pushing that shaft upward as it spins? I don't claim to understand this. I just know we're not moving fuel. And there it goes all the way down. All right, I'm going to spin it again. Yeah, it's positively engaged. You can't. Yep, I find this very confusing here. Well, let's lay that out. We know we have the little ball. At this point, I think we want to clean all these things, make sure we have nothing blocking any of these spots. Okay, I'm just going to pull out the rest. Yep. Yep. It's a really shallow nut, and almost like it needs a specialty thin wall socket. So it's pretty simple. It's just a little coil, pushes that down, and there's a little spring loaded in there. So I'd say the coil retracts, it allows fuel to go by and fill that up. Alright, we can actually test that. We'll just use a little battery. So the fuel should come in through the bottom hole. There's the opening to let it come up through the other spot. Little O-ring there. I guess at this point, you know what, we're just going to use a little compressed air. Make sure everything's nothing blocking anywhere. And alright, so let's get an air hose. Alright, we're just going to apply a little bit of air to the input. So a little O-ring came out the output side under that brass washer. I was not expecting it to go through, so let's check that out again. There's nothing on the paper towel. Oh. Oh, look at that. There's the other little orifice on the outside. And that may be the problem, guys. There might be a clog in there. Let's see how far this guy will go through. I'll have to go back to the drawings. I don't remember seeing a breakdown of this little assembly here. But I'm going to assume this little O-ring around there. I think there's supposed to be a hole all the way through there. Got a little safety wire that's kind of small. Maybe we can. Okay, it's a spring-loaded check valve in there. Alright, so well, if that's where the fuel is flowing out, the check valve is going to have to go to the, so it can push open. Yep, it is working. Maybe it was stuck. Maybe there was something in it. Okay, well, now we know why that little set screw was there. Let's see if we can blow some more air through things. Alright, this is the feed to the nozzle. Let's spray a little through here. Well, looks like everything's super clean. I'm going to spray everything one last time. And we're going to start reassembling it. Alright, so coming through the input. So that's clear. That's the input. And there is some kind of bypass, so I guess if it builds too much pressure, it comes through the bypass. And there's another hole here, which is going to be through the gear driven. And that goes through the nozzle, and that works fine. And this is the other hole. That goes to the, excuse me, that hole goes into the solenoid. And that one's clean. If we go through the output here, that all seems connected. All right, well, let's start putting our gears back together. So really, we need to take this little plate, get a little bushing in there. It turns real smooth. Well, in theory, if that shaft moves outward when spinning, so I want to make sure that everything's clean in there. It all looks good. Spins freely. No real burrs. All right. I'm going to set this down for a second. So we have to put that little ball back in without dropping it. I have to go get a little pair of tweezers. Okay, we have the ball in there. Alright. Have the gear slid over it. So that's captured. Slide the driven gear on. So here's the little assembly. Seems to spin real nice. Alright, we're just going to set that gently there. Bring our unit back. Give it a good wipe down here. What I did was push down on that shaft until that flat spot slid into the thing. There you can see everything spinning. And this is what I don't know about. If I push down on that shaft, it goes down deeper than that piece, and then it's not engaging anymore. So what causes that shaft to push upward and engage? That's the reason it's not working. So is it something when the fan's spinning, the shaft pushes up, engages the ball, and the pump's working? Or are we missing something here that we don't know? And we don't have any breakdown drawings of that part. What I wonder, was there a little tiny bearing, because I did take this apart yesterday, is there a little bearing that was at the bottom of that shaft when it came out and it dropped somewhere and I have no idea? And that would hold that shaft up where it engaged all the time. Alright, I think I'm going to do a little bit more research here, but yeah, I think that that shaft needs to be pushed up. And I bet you there was a little tiny bearing under there. So, alright, we'll get back in a little bit, guys. I believe this is the problem. You see the shiny bushing down there? I believe the shaft over time has slowly eaten that away and pushed downward, and so that allows the shaft to slide far enough down that it's no longer, the ball's no longer engaging our small driven gear or the fixed gear. I did find some copper little shavings in there the first time I cleaned it out. I didn't think much of it, but I believe if we can space the shaft back up, it'll be engaging and the fuel pump will be on, and then we'll solve the problem. So I think I just finally got to the point that it ate enough of it away that it slid down and wasn't engaging the gear. So we're going to find some shim material and see what we can put down in that hole. We need to raise it up 90 thousandths after measuring it, and that should keep everything engaged. Alright, we have shimmed with a little copper washer, but I don't know, it's really more of a testing fix. It's not a long-term solution because there's a gasket under there, and I don't know what's going to happen here. Yeah, it does bind it up a little. Don't think we can make this work. Yeah, it's already starting to bind with that little spacer in there. And we don't have a lathe or a mill, or we could actually just go to the opposite side of the shaft and move that little baldy tint up 90 thousandths. Yeah, that locks it up, assuming that the shaft is not hardened. So we pulled out the little gasket. So as there was a little copper spacer I added. Yeah, see that? I need a little bigger hole in there. So the shaft size is 0.236, but the bushing needs to be 0.303. Well, let's go on McMaster and see if I can find anything like that. Well, it's been about 2 days since we did an update. So just to do a recap, what I found is that our spinning shaft here had slowly eaten into this bushing. What I was able to do was order a shim. It's 0.302 inches in diameter, 0.236 inches ID, which is almost exact for the shaft. I then sorted through the bag of shims that I got in and chose some that were just a little bit on the OD was a little bit smaller, and that would slide on the shaft real easily. And just to give you an idea what we did here, if the camera can even pick this up, there's a little shim washer. It just fits right on there. What I've actually done is right here I have one shim in place. It dropped down in the hole that was that this slowly ate away. I was actually able to pick out a few little pieces that were still worn down inside that little hole. And we are just a little bit below the surface. So I think we're really good. This is a 30 thousandths thick shim. I tried just a hair larger, but that did not, or excuse me, I tried stacking 2, and I think that binds on the fan a little bit. So I think we're actually ready to put things back together and give it and make sure that that fan is spinning freely and both gears are fully engaged. All right, let's get started. And just to give you an idea, I don't know if we already showed this yet. There's another little brass bushing that was pressed into the steel. This one's good because for whatever reason the pressure was going downward and eating that bushing. This one is just perfectly smooth, can't even feel a fingernail difference. Get our little gasket in there. This is the part to keep holding tight so the ball can't pop out. And what we need to do is slowly spin the, push down and slowly spin the fan here. There. Now what we can do is a little test. We may have to put the other shim in. So that shaft pushed down a little farther than before. As you can see, the gears are spinning. I think we're good with the 30,000 shim. So, alright, now I think we'll do and we're just going to put our screws in and make sure we're going through the gasket, not pinching it. That's good. It should not leak. Or it should exactly, sorry, it should not hold pressure. So let's leave the check valve out for a moment. And we need to reassemble the top here. Actually, let's try the check valve. Alright, there's a little O-ring on the top of the check valve. That's just going to drop in. This screw just locks everything in place, holds that check valve, goes up against that O-ring. So basically they want about $700 for this silver pump housing. Let's go a little snug. So we've ended up fixing it with about a 50-cent shim. All right, get our banjo bolt back on. Actually, you know what we should do? Nope. I never did figure out the purpose of this plug, because that hole is plugged in there. I think it really is for some kind of bleeding, but somebody capped it off. So we're not going to tear in that. It looks like it even has a little green dot, so it might have been a factory. It had been a factory setting. Alright, I'm not sure what that's doing, but we've tightened it back down. Alright, grab our banjo bolt, put the copper washer back on. And I have extra copper washers, but they're not this thin. And they seem to throw the alignment out just a little, so. Normally I'd like to replace the crush washer. So I put the vacuum gauge on the output side, and what we're really going to listen for is see if we can hear that check valve moving. And I can. Every time I do that, I think it was a little stuck earlier too. Just the slightest pressure, I can hear it opening. So that's great. The nozzle block. We're going to get our little can of diesel. Just kind of lubricate things just a little. And our little test bottle. Alright, that little orifice is going to match up to that one. Drop in place. Okay, everything's there. Yeah. With the taper in the nut and the taper in the socket, it just doesn't grab well. Okay, that's in there snug. Now, take our wavy washer. It's a little spring Belleville. The metal clip. It just kind of floats. It's odd. And remember, there's a recess on one side of the nut. Just going to hold it in place and just tighten that down here. Okay. Well, let's pull vacuum now that we've closed off that. It should not hold vacuum yet because we haven't plugged this end. So let's get our electrode. I think if it really wants to, it'll just spin freely. And the stainless steel washer might spin a little and just eat more of the bronze. Alright, that's all fine right there. Alright, let's get some of these wires routed. So the orange wires are for a little heater block. If I understand it correctly, we get to a certain temperature. If it detects temperatures below a certain threshold, and I don't remember what it is, it'll warm that block. Alright. We'll sneak our solenoid one over here. Some of these fit really snug. Okay. So at that point, we're all locked together. Suppose what we could try now before we go a whole lot further, see if we could suck in any, kind of get things primed. Alright. We have fuel going through the whole thing now. Let that drain back. Alright, let's try not to make a mess here. Try to get this, any stuff that's down there, get that clean so we can check for leaks. Probably run it for a while. Maybe run an hour, check it out. Okay. The little retaining clip. Perfect. You know, I don't really think there's anything wrong with the old nozzle after looking at everything, so we're going to put that one back in. You can see it just looks perfectly brand new. And we'll save this brand new one, put it in our miscellaneous parts bin. Ideally, I'd probably pre-soak it. All right, that's nice and snug. Put our electrode back in. All right, that's snapped in tight. These are already preset, but you're not supposed to bend them, but they give you a gauge to check everything. I know it's all good. So at this point, we have everything put back together. I guess we're ready to load it in and give it a test. So let me reset up and we'll start there. All right, back here in the engine room. Sorry for the noise. It's the circulation pump. And as a side note, we do have one of the chillers actually working as a reverse heat pump. It's been working great for 3 days, but we want to get this back together. Try to keep my head out of the way as much as I can. All right, so we have to turn these back. Currently they're circulating through the chillers, and we need to circulate back the other way. And these are some of the hardest things to turn. We're going to turn it on, slide this into the red wire and the yellow wire with red stripes. Take it out. Turn it off. That should reset it. Let's try again. It is running. Let's go take a look at how the exhaust looks. guys. Looks like everything is running.